Okay, I've been seeing a lot of issues with elementary equilibrium problems and setting up ice tables, and I'm just going to do another quick video. This is activity 3, and question number 1 that I want to go over. And it's the first question. It doesn't necessarily mean it's the easiest, and it's got a lot going on in it, and that's why I'm picking it. And you can see we just have a generic equation here. We've got A plus B in equilibrium with 3C plus 2D. And they're all gaseous. So we can talk about concentration. Now, in this case, you're given, or the question states that you start with 2 moles of A and 4 moles of B. And all of these gases are mixed together in a 0.5 liter container, or 500 milliliter container. And that's sealed, obviously. The other thing that the question tells you is it gives you the equilibrium, the number of moles at equilibrium of C, which is 0.3 moles. So we know what C is at equilibrium. Now, one of the things that I've been telling people, and I've kind of been seeing, is you're given moles, but you really want to be working with concentration, because that's what the equilibrium is all about. So I have a tendency to steer clear of moles. In other words, I'm going to convert these to concentration right away. So I know that my volume is 0.5 liters. So when I start my ice table here, instead of starting with 2 and 4 moles, I know that I've got a concentration of 4 and a concentration of 8. And obviously I'm starting with 0 and 0 here. So now when I do my change, I'm looking over here, and remember I've got coefficients here. So this is going to be 3x and this is going to be 2x, and we're adding that because our product concentration is going to go up. At the same time, our reactant concentration is going to go down. So we're going to be subtracting x and subtracting x. Why? Because it's a 1-to-1 ratio, so we're only taking off 1x here. So then our equilibrium concentration is going to be 4 minus x, 8 minus x. And since we know what this is, and I'm just going to do it quickly over here, we know that the concentration of C is 3 moles. Or sorry, it was 0.3 moles. I apologize there. So at equilibrium, 0.3 moles divided by 0.5 liters means that we have a concentration of C at equilibrium of 0.6 molar. I don't know if you guys can see that on the edge there. So I know that my concentration at equilibrium is 0.6. And then this is going to be, 2x. Okay? So what I can do is I know that 3x has to equal 0.6. So 0.6 equals 3x. So x is obviously 0.2. So that is the molarity of C at equilibrium. And now that I know x, I can plug it into here, so I know that this is going to be 2 times 0.2, so that's going to be 0.4. And over here, I'm going to have 4 minus 0.2, so that's going to be 3.8. And 8 minus 0.2 is going to be 7.8. So here are my equilibrium concentrations for each of the 4 substances. Okay? Now I'm ready to do my equilibrium expression. So I'm going to come over here. I'm just going to switch boards here. Actually, I'll just go right like that so we can still see that. And I know my K expression is going to be C cubed D squared all over A and B. So now I can plug in my values from the previous board. C was a 0.6 cubed, D was 0.4, and that's squared divided by 3.8 and 7.8, and those are not squared or cubed because there's again just the 1-to-1 ratio. So if we finish up this calculation, then this is going to come out to 1.17 times 10 to the negative 3. So that's our equilibrium expression. So just to recap, a couple of things that I find, again, useful is that you put everything in concentration right away, and then your ice table is all in moles per liter. And the other thing you have to watch out for is, of course, the coefficients. So making sure that you start with a balanced equation. In this case, you were given that. Take the information you're given, so the initial concentrations, and in this case you're given the equilibrium concentration of C, so you can work backwards to solve for X. And then plug in X for the other values, and there you go. So that is question number 1 from activity 3.